Hi, my name is Claire Jackson, and today I'm going to be solving systems of two linear equations using the substitution and the combination method. Okay, so to begin, the equations I'm going to be using are y equals negative 2x plus 9 and y equals 1/2 x plus 4. Okay, once I have this written out, I'm going to begin solving. So this is what it should look like. And now we're going to start solving, and we're going to do, okay, so we need to put these equations on both sides because we're going to be solving for x. So we're going to have negative 2x plus 9 equals 1/2 x plus 4. Okay, now that we have this, we're going to start solving for x. So we need to isolate x just to the left side of the equation. And to do that, we're going to need to subtract 1/2 x from both sides of the equation. So I'm going to subtract 1/2 x from the right side of the equation, which will give you 0. So it'll cancel out. And then I'm going to subtract 1/2 x from the left side of the equation. Now, because our 2 is negative, this will add the two numbers together. So instead of actually subtracting 1/2 from 2, we're going to be adding 1/2 to 2. That will give us negative 2.5. But we want to make this a fraction, so it's going to be an improper fraction, but that's okay. We're going to, to solve an improper fraction, we're going to take our denominator right here, and we're going to add our denominator to this whole number. And then once we add our denominator to this whole number, that gives us 4. And then we're going to add our 4 to our numerator, which will give us 5. Okay, so now, I know that looks kind of confusing, but now we have negative 5 over 2, and we can't forget about our x, so we have negative 5 over 2x. Perfect. Okay, now we still have our plus 9 on the left side of the equation and our plus 4 on the right side of the equation. So we're gonna take this, and we're gonna do our plus, or it's a positive 4, it's not a plus 4 anymore. Okay, now we need to isolate what is not x to the right side of the equation because we just want x on the left side. So we're going to subtract 9 from both sides of the equation, and so negative 9 minus 4 is going to give us negative 5, and the way to solve that would be to add 4 to negative 9, but because it's a positive number, it's going to bring that negative number up closer to a positive 0. So it's still in the negative, so we still have a negative 5. Okay, so now we have negative 5 over 2x equals negative 5 because we solved this out. So that is this bottom part right here. Okay, now once we have this solved out, our negative 5s on both sides, if you notice, we have negative 5 on both sides. Those are going to cancel each other out. So we're going to cross out both negative 5s, and that leaves us with 2x. Therefore, our answer to this equation is 2. So x equals 2. So we're going to write that down because we need to remember this when we go back to solve for y. Okay, so I'm writing down x equals 2. Now, once I have x equals 2, we're going to substitute that in to our second equation. Or actually, we can just use our first equation. We're going to substitute that into our first equation. So we're going to write out again, y equals negative 2, and then in parentheses, we're going to put 2 again because wait, let me make sure I'm doing this right. I'm sorry. Okay. So now that we have this, we are going to substitute in our 2x. I was doing it right. And we're going to put y equals negative 2, put in parentheses 2 next to that because that's usually where that x goes. And then we're going to do plus 9. Okay, now to solve for this, we're going to multiply, and it's going to be negative 2 times 2, which is going to be negative 4. Negative 4. And then we have our positive 9 still, so we're going to have our plus 9 on the other side. And since there's no x or y left on this, we can solve, and that will give us, so negative 4 plus 9 will give us a positive 5, which means y equals 5. So for our equation, our x is x equals 2, and our y equals 5. Now, we can take these 2 points and put them on a graph, but you can solve them using a graph, or you can just solve it using this way. Okay, so now if we put those 2 points on a graph, it'll line up perfectly and intersect right there. All right, that is how you solve using the substitution method. Now we're going to solve using the linear combination method, but we're going to use a different equation. For this equation, we're going to use, here's my work for step 1. If you want to write all of that down. Sorry, my work is messy. Gets the job done. Okay. Now, for the linear combination method of these 2 equations. So we're going to do the equation 3x plus 4y equals 2. That's our first equation. 3x plus 4y equals 2. And now for our second equation, we're going to do negative 3x plus 8y equals positive 1. Okay, so the way we're going to solve this is we're going to stack those 2 equations. So the first one I read, 3x plus 4y equals 2, is going to be on top, and then right below it, I'm going to write negative 3x. I'm sorry, that's my dog. I'm going to go close my door really quick. Okay, now we're going to do, sorry, let me gather my thoughts. Okay, I'm stacking these 2 equations. That's where I was. So now, once I stack these 2 equations, we're going to have 3x plus 4y equals 2 on top, and negative 3x plus 8y equals 1 on the bottom. Okay, I'm going to draw a line under those just to keep it neat. So that's that equation right there. And then this part is actually quite simple. We're just going to add. We can add. We've been adding since kindergarten. Okay. So 3x minus 3x is going to be 0. So that cancels out, and you're going to have a 0 right there. So I'm just going to cross through my 3's because I can forget about them, and I don't want them getting in the way. I don't want to see them again. Okay, now that I've forgotten about my 3's, we're going to go to the 4y and the 8y that are stacked above each other. So we're going to add these 2 together because they have the y. They can add. So we have 8 plus 4. That equals 12. So we're going to have 12y, and I'm going to write this under the line. So there's my line right there, and I wrote it under the line so I can keep track of it. And now we're going to add, we're going to put our equals sign on there, and we're going to do 2 plus 1, 3. Simple math. Okay. From there, we're going to take our 3, and we're going to need to divide our right side of the equation by our left side. So we're going to put 3 over 12 over 12. And once you have 3 over 12, you realize that 3 over 12 is also equal to 1/4. So I'm going to substitute down to, not substitute, just 1/4. Okay, so now we have y equals 1/4. Now that we have y, we can solve for x. Perfect. Okay. Now, in order to solve for x, we're going to substitute in our 1/4 y that we got to give us our number. Okay. Our x and our y. So we're going to go in with our 1/4 on the, we're going to use our top equation again. That's just the easiest thing to do. So we're going to use 3x, I'm writing it out again, 3x plus 4y, but instead of putting the y in there, we're going to put 4 parentheses 1/4. Okay, and then we're going to do equals 2. So once we have our equals 2, this is what that's going to look like, this equation right there. And then once we have that, we're going to combine, so we need to multiply 4 times 1/4, which is going to be 4/4, and that is equal to 1. So we're going to put 1 down here, and then we're going to have 3x plus 1 equals 2. Now, again, we want to isolate x on its own, so we're going to subtract 1 from both sides of the equation, and that will give us just 1, because 1 minus 1 is 0, and then we're going to do 2 minus 1, and that is also going to be 1. Okay, so now we have 3x equals 1. Okay, now we're going to do like we did before, and we're going to divide our right side of the equation by the left side of the equation. So we're going to put 1/3. Now that we have 1/3, we know that x equals 1/3. So our y is y equals 1/4, and x equals 1/3. And here's my work to show how I got that. That is the linear combination method. All right, thank you for listening and working with me today.